Today I'm going to talk about the sum and difference rules for finding derivatives. The sum and difference rules go like this. If you remember, this was our notation for finding a derivative, and we're going to find the derivative of some f of x function added or subtracted to another function. We'll just call it g of x. And there can be more than two functions added or subtracted. This could be f, g, h, I, j, k. We could have a whole bunch of functions added or subtracted. But if you have the sum or difference of functions, you're trying to find the derivative of it. All it is you find the derivative of the first function, f prime of x, and you add or subtract, depending on what you're given, the derivative of g prime of x. This is pretty simple. For example, if you have something like y is equal to x squared plus 5x minus 3, you can imagine all the work that would be involved in finding the derivative of this function using the definition of the derivative, f of x plus h minus f of x all over h, and taking that limit as h goes to 0. But what we have here is we have a sum of these two terms and then a difference. So what it means is we can just find the derivative of each term in this polynomial. So all it is y prime is the derivative of x squared, which is just 2x, plus the derivative of 5x, which is just 5, minus the derivative of 3, which is just 0. So the derivative of x squared plus 5x minus 3 is just 2x plus 5. And let's find y prime of a particular value. Let's find y prime of negative 3. All you have to do is substitute in negative 3 in for that x, and you get negative 6 plus 5, which is negative 1. So the slope of this parabola at x equals negative 3 is negative 1, or the slope of the tangent line to that parabola. Let's get just a little longer example here, actually a different type of example. Let's have 4 over x minus 4 over x squared plus 4 over x to the third power. So we can just take the individual derivatives of each one of these terms. So the derivative, actually let's rename this. Well, we'll call this y equals, and we can call this y equals 4 times x to the negative 1 minus 4 times x to the negative 2 plus 4 times x to the negative 3. And to take the derivative of this, y prime is equal to negative 1 times 4, which is negative 4, x to the negative 2, subtract 1 from that exponent, minus, but now we have a negative 2 times negative 4, which is positive 8, times x to the negative 3, subtract 1 from that exponent. Now we have negative 3 times 4, which is negative 12, times x to the negative 4th power. And then we can write this in fraction notation like it was given to us, and we can call this negative 4 over x squared plus 8 over x cubed minus 12 over x to the 4th. And there's the derivative of that original problem. Now let's get one that's a little bit trickier than that even. Let's do 6 square root of x times the cubed root of x minus 2x plus 6. What we're going to have to do with this example is we're going to have to distribute 6 square root of x into each one of these terms. But the first thing that we'll call this y equals. Well, the first thing we're going to want to do is turn all of those two radicals into rational exponents. So this is actually 6 times x to the half times x to the 1/3 minus 2x plus 6. And now to distribute this, we get y is equal to 6 times, when you multiply with the same bases, you're going to add those exponents. 1/2 plus 1/3, well, that's 3/6 plus 2/6 is equal to 5/6. So we have 6x to the 5/6 power minus 6 times 2 is 12. This is x to the first, and 1 plus 1/2 is 3/2, plus 6 times 6 is 12, x to the half. And there's our original y function, or f of x function. And now to take the derivative of this, all you're going to do is use the power rule on each individual terms. So you have 5/6 times 6 times x. 5/6 minus 1 is negative 1/6. Minus 3/2 comes down front, and you multiply that by 12. You subtract 1 from that exponent, and you get 1/2. Plus 1/2 times 6 is 3, and 1/2 minus 1 is negative 1/2. So now to clean this up a little bit, let's do 5/6 times 6, which is 5. And we have a negative exponent, so that goes in the denominator. And to the negative 1/6 means in the denominator it is the 6th root of x. Now we're going to multiply 3/2 times 12. Whoops, I forgot my x here. Thought that looked funny. Well, 3/2 times 12 is 18. X to the 1/2. Well, x to the 1/2 is the square root of x. And then the last thing we have is 3x to the negative 1/2. Well, the x to the negative 1/2 comes to the denominator. 3 stays in the numerator, and that becomes the square root of x in the denominator because of the negative exponent. So there is your derivative of that original problem, which was a little bit sticky, but it was interesting. Here's another example that we'll look at in the next rule. What if you had something like 2x minus 3 squared, y equals? Well, there are a couple of approaches to take to this problem, and you'll see a second approach when I get to my second rule of differentiation. But for right now, what we're going to have to do is we're going to have to FOIL this. So this is 2x minus 3 times itself. So y is actually equal to 4x squared. Minus 6 is minus 12x plus 9. And now to take the derivative of that, 4 times 2 is 8, times x to the first, minus 12, and the x goes away, and then the derivative of 9 is 0. So there is your derivative for that example. So that's the sum and difference rules. The next rule I'm going to go over is something called the product rule. Hopefully this isn't as blurry as it was yesterday. The product rule. And if you're numbering them like we started out yesterday, this sum and difference rule would be number 4 in our list of rules. And then this product rule would be rule number 5. So this product rule is the most complicated rule that we've encountered so far. And it goes like this. If you have a product of two functions, let's say f of x times g of x, which is the product of two functions. How you're going to find the derivative is the first function, f of x, times the derivative of the second function, which is g prime of x. So first times the derivative of the second, plus second, which is the g of x, times the derivative of the first. And we'll say it like, I mean, this is how we write it, but when we say it in class, we'll say first times the derivative of the second, plus second times the derivative of the first. So this is a really powerful and important rule of taking derivatives. That's the product rule. And what does it look like in action? Let's say we have y equals 4x minus 2x squared times 3x minus 5. We're going to take the derivative in two different ways because we know a couple different ways. First, let's FOIL and use the sum and difference rule that we just learned. This is the first way, or method. This is the first method. So if we FOIL this out, we get 4x times 3x, which is 12x squared, minus 20x, minus 6x to the third, plus 10x squared. And we have two, this is just y, and we have two like terms to combine, and I'll write this in standard form with the negative 6x cubed coming first. 12 and 10 is 22. X squared minus 20x. Well, there's y after we FOIL it, and if we wanted to get y prime, we can just use our power rule on each individual term. So negative 6 times 3 is negative 18, x to the second, plus 22 times 2 is 44x, and then minus 20. So there's y prime using FOIL. Sometimes it's easier to FOIL something out first and then use this method. Sometimes it's easier to use the product rule. Now let's use the product rule. The product rule says, let's say f of x is equal to our first function, or our first part of that function, which is 4x minus 2x squared. And let's say our g of x is equal to 3x minus 5. You don't have to put those in parentheses. I don't know why I did. But anyways, here's our f of x times g of x. Or that's y equals. I guess I should keep it consistent and call it y. So now if I want to find the derivative using the product rule, I use the first, which is 4x minus 2x squared, times the derivative of the second. Well, the derivative of 3x minus 5 is just 3. And then you have to add to that the second function, g of x, which is 3x minus 5, times the derivative of the first. The derivative of this is 4. The derivative of 4x is 4. And the derivative of minus 2x squared is minus 4x to the first. And hopefully this y prime is equivalent to this y prime. It's the same function, we just used two different methods to find the derivative. So let's clean this up a little bit. Distribute the 3, and you have 12x minus 6x squared. If you FOIL this out, you have 12x minus 12x squared minus 20 plus 20x. And let's combine the like terms. Let's see. We have negative 6x and negative squared and negative 12x squared. That looks like it's negative 18x squared. Now let's take the x's. 12x plus 12x is 24x plus another 20x is 44x. And I like to get rid of them after I combine the like terms. And then the only thing we have left is minus 20. So there's our y prime, negative 18x squared plus 44x minus 20. And we got the same exact thing using the FOIL method. So if these aren't the same, then you did something wrong in one of the two methods, but this is using the product rule. And they should both be the same. Sometimes the product rule is easier. Sometimes it's easier to FOIL and take the individual derivatives. You're just going to have to make that call for each individual function that you encounter. Let's do another example. Let's do the example x squared minus x plus 1 squared, y equals. Well, what are we going to do with this? Well, we could use the FOIL method, or it's actually more than a FOIL. We would have to multiply x squared minus x plus 1 by itself, which isn't too hard, but it's a little bit more involved than FOILing like the last problem, just a little bit. So what I think I'm going to do is I think I'm going to make it a little bit easier by using the product rule, since it's probably just a little bit faster. And the product rule says we're going to let our first function be f of x. We're going to let our second function be g of x. Even though they're the same thing, we still call them f and g of x. So the derivative of this function is the first f of x, x squared minus x plus 1, times the derivative of the second. Well, the derivative of x squared is 2x. The derivative of negative x is minus 1. The derivative of 1 is 0. So there's the first times the derivative of the second. And then you have to add that to that, the second, which is g of x, x squared minus x plus 1, times the derivative of the first. Well, the derivative of the first is just 2x minus 1. So this is our g of x, and this is our f prime of x. And the only thing we really should do is we should recognize that these are both exactly the same. And when you add two terms that are exactly the same thing, all you have to do is put a coefficient of 2 out in front because you have two of them. So it's 2 times x squared minus x plus 1 times 2x minus 1. And I would say that you didn't have to multiply those out. It doesn't make things any easier. For example, if you want to find, let's say we want to find y prime of 1. We want to find the slope of this function when x equals 1. Well, it would just be 2 times 1 minus 1, which is 0, plus 1, which is 1, times 2 times 1 is 2, minus 1 is 1. So the slope when y equals 1 is just equal to 2. And it's not any easier if you multiply those out. So there's the product rule. And let's see, I'll give you one more example if you want to try one on your own. I'll just say you try this. It would be great if you could try this before class. Let's say f of x is equal to 3x squared minus 2x plus 5 times negative 5x to the 4th plus 2x cubed minus 7x squared plus x plus 2. And you can just about imagine what it would take in order to find the derivative of this function using the definition of the derivative. That would take all day. In this example, it might be easier to distribute the 3x than distribute the 3x squared, to distribute the negative 2x and to distribute the 5 and combine like terms and take the individual derivatives. But I think it would probably be easiest if you use the product rule. First times the derivative of the second plus second times the derivative of the first. So I'll turn the video off right now, and you can give that a shot, and we'll get practice on this product rule tomorrow in class.